Hello and welcome to another stream. Welcome to the Jha.G channel. क्वांटिटेटिव एप्टीट्यूड पढ़ने वाले हैं. ओए हार्पिक दिख रहा है मैं. हार्पिक ऑन यूट्यूब. व्हाट? मेरी आवाज जा रही है क्या उधर? मेरी आवाज जा रही है क्या उधर? नहीं जाएगी. तू कुछ बोल. अरे आराम से बोलना. बोलते रहे. हाँ. They ain't picking you up. The mic ain't picking you. तो जैन लोग यहाँ नहीं आते. नॉन वेज माइक. कितनी देर की मीटिंग है भाई? Here's my link to the stream. Here's the link to the. Oh, I Kavli reporting. आज लीनियर एंड क्वाड्रेटिक इक्वेशन खत्म करेंगे. या लेट्स रेडी टू रंबल विद द जंबल. कुछ. ओह नो मैन. इस दिन एक्चुअल कंटेंट एंड प्लानिंग के साथ भी आऊंगा. दिस इज जस्ट स्टडीइंग स्ट्रीम एंड नोबडी इज गोना. डू 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 डू. कोई ना साहिल भाई. पढ़ने ही वाले हैं. कुछ होगा नहीं यहाँ पे. जाने वो कैसे लोग प्यार को प्यार मिला. जो भी कसम खाई थी हमने, वादा किया था जो मिलके, तू ही तो लाया है जीवन में मेरे सवेरा. क्या तुम्हें याद है? क्या तुम्हें याद है? क्या तुम्हें याद है? हाँ मुझे याद है. हाँ मुझे याद है. Yeah. Thank you, thank you, thank you, thank you. F operator. Recently, बड़ा कहाँ गया हुआ है? बादल हम तू ही तो लाया है जीवन में मेरे सवेरे। यही गाना गाया जा रहा हूँ मैं भाई, मेरे मुंह पे चढ़ गया है। उदित नारायण सुप्रीम, लुक एट माय नेम, हाउ आर माय हैंड। भाई पढ़ ले बैंड के लोग भी बोलते रहता है। पढ़े नो यू, बकचोदी करवा लो या ऐसे। हाँ,
Now, the most easiest, let's say, out of the three, in terms of order, number of variables, and number of terms, the number of, let's say, variable over here. As we can clearly see in this particular case that the three, we can see a x, we can see a y, we can see a z over here. Number of variable in the given expression are three, but that doesn't, let's say, help us to eliminate any of the options. Now, the trick about suppose the number of term basically would be because most I have likewise term, they can be added and they can be converted into a single term. For example, I can, let's say, talk about the term 3x and 5x basically as a like term. And suppose if I talk about the addition of 3x plus 5x, it is going to become 8x over. So please, out of the three, terms of order, number of variables, and number of terms, the number of, let's say, variable over here. As we can clearly see in this particular case that the are three, we can see a x, we can see y, we can see a z over here. Number of variable in the given expression are three, but that doesn't, let's say, help us to eliminate any of the options. Now, the trick about suppose the number of term basically would be because most I have likewise term, they can be added and they can be converted into a single term. For example, I can, let's say, talk about the term 3x and 5x basically as a like term. And suppose if I talk about the addition of 3x plus 5x, it is going to become 8x over. Now, the most easiest, let's say, out of the three, in terms of order, number of variables, and number of terms, the number of, let's say, variable over here. As we can clearly see in this particular case that the three, we can see a x, we can see y, we can see a z over here. Number of variable in the given expression are three, but that doesn't, let's say, help us to eliminate any of the options. Now, the trick about suppose the number of term basically would be because most I have likewise term, they can be added and they can be converted into a single term. For example, I can, let's say, talk about the term 3x and 5x basically as a like term. And suppose if I talk about the addition of 3x plus 5x, it is going to become equals to 8x over. So please note the likewise term basically can be combined so that we can reduce them. So a most common mistake in this particular case would be people might say we have seen 1, 2, 3, 4, 5, 6, 7, and 8. These are the 8 term, and yes, there could be a possibility of expression having exactly 8 term, but we have to look for likewise term and which can be simplified. Now, one trick regarding the likewise term to spot easily would be nothing but to write them in the alphabetical order. Right? What I meant basically was to write the number x before y. In this particular context, I will rewrite the first term as x power 4 plus a y raised to 5 plus 3x square y plus a 7y minus 4x cube y cube. The next term as plus 2xyz. As of now, each of the term happens to be unique in nature. Next term, if I look at properly, one can see a minus 3yx square. Now understand this particular term I can also write as minus 3x square y and then a minus 4 in this particular case. And now suppose if you look at one thing over here that the term 3x square y and minus 3x square y are likewise term. And if you simplify them, this particular term can be completely vanished. And hence what we get is x power 4 plus a y power 5 plus a 7y minus 4x cube y cube plus a 2xyz minus 4. And as you can clearly see now that these are nothing but 6 terms over here, which means option number 1 and option number 2 as of now can be ruled out. Option number 3, option number 4 basically remains. Now, how do we find out the order of this expression? Now, in this particular case, what we can do is, if I suppose have a single term, we can simply look at the highest possible, let's say, power, which right now at this particular moment, people, if you can see, is nothing but 5. And many of us at this particular moment will be tempted to choose, let's say, option number 3 as the answer. But let's say be slightly careful. And we try to find out the order of the expression in that particular case. Moment suppose we have a term containing two variable or three variable, we try to add the sum of the powers. So in this particular context, for example, this particular term 4x cube y cube, if you look at the addition of these two powers, they become equal to a 6. In this term 2xyz, if I look at the sum of the powers of x, y, and z, that become equals to a 3. So sum of the, let's say, powers of the variable x, y, and z, the highest power in this particular case happens to be a 6, and that comes in the term 4x cube y cube. And that is why the order of this expression happens to be 6. So one can safely choose to mark option number 4 as the answer for this particular question. In the next sum, it is given that simplify, and the expression given to you is 3x cube. Let's write it down. 3x cube plus 4xy square plus a y cube minus the next term is written as 2y square x. I will write them basically as minus 2xy square. It becomes similar to the term 4xy square. Then suppose if I distribute the 3x inside the bracket, so 3x into x square will become 3x cube, and the term 3x into y square will become equals to a plus 3x y square. The moment suppose if I think of combining the term, let's say 3x cube and 3x cube can be combined together. Again, these two are the 3xy square minus 2xy square. That will become equals to nothing but one can say plus 5xy square. And then finally, we have the term plus a y cube as well. So if someone look at the term 6x cube plus 5xy square plus a y cube, they will find option number 1 is the required answer for this particular. In the next sum, it is given that simplify, and the given thing is 5x plus 4y times 4y minus 5x. So again, we can take the help of some known algebraic formula. What I can do is I can rewrite, suppose, the first bracketed term as, let's say, 4y plus 5x times 4y minus 5x. Now, by doing this, we are able to, let's say, get something in the form of a plus b into a minus b, which is equals to a square minus b square. So this particular expression I can rewrite as 4y whole square minus 5x whole square. And the term 4y whole square become equal to 16y square. Then a minus, the term 5x whole square will become equals to a 25x square. So the required answer I'm looking for must be equal to 16y square minus 25x square. And if I look at the given options, option number 1 is the required answer for this particular question. In the next sum, again, the target is to simplify the given expression. And what we will do is, let's say we try to open the bracketed term. So that answer for this particular question. In the next sum, again, the target is to simplify the given expression. And what we will do is, let's say we try to open the bracketed term. So the first term is 3p minus 4q. The next term can be simply opened without changing the sign, plus a 5p plus a 2q. Now then we have minus of 8p minus 2q. If I open the bracket, sign basically will change, minus 8p plus a 2q. And then what we can do is you can simply combine the term, let's say p and the term q. So 3p plus 5p happens to be a 8p, and 8p minus 8p will become equals to 0. This three term together basically will become equals to a 0. Then what do we have? We have a minus 4q plus 2q plus 2q will become another 4q. So again, a minus 4q plus 4q will get cancelled out, and the required result will become equals to 0. So option number 4 is the required answer for this. In the next sum, it is given that if 12 is added to 3 times a number, and option number 4 is the answer for this. In the next sum, it is given that if 12 is added to 3 times a number, and the result is divided by 5, the original number is obtained. Find the number. So let's say we assumed our number to be equals to x. And let's read the first sentence again, the first part of the first sentence again. If 12 is added to 3 times a number. So first of all, 3 times of a number happens to be nothing but equals to a 3x. Because we assumed our number to be equals to a x. And in this 3x, we are going to add the number 12. We did this. So if 12 is added to thrice a number, it simply means 3x plus 12. And this result, which is 3x plus 12, you now divide by 5. So I will divide this 3x plus 12 by 5, and the required result is nothing but same as the original number, which I have assumed it to be equals to a x. So we are able to form a simple equation in x, and now we can simply go for cross multiplication, and solve for the value of x. Inside, one will get 5x minus 3x, giving you a 2x is equals to 12. And now divide by, let's say, 2 on both sides. So if 2x is 12, x become equals to 12 divided by 2, or simply a 6. So required number in this particular case happens to. In the next sum, it is given that if a number is multiplied by 10, the resultant number is the square of the original number. And again, the question says that find out the number. So in this particular case, suppose if I again assume my number to be equals to x, and if I reread the first part of the first sentence, if a number is multiplied by 10, it simply means when the number, let's say x, is multiplied by 10, will become equal to 10x. The resultant number happens to be nothing but square of the original number. It simply means that the result will be equal to nothing but x square, because we have taken x as our original number. So now many of you can possibly make a mistake in this particular case. When we get x square equals to 10x, we can say that x should be equals to 10. But normally when you cancel, let's say x on both sides, you assume that x is not equals to 0. So here I will rewrite this as, first of all, x square minus 10x equals to 0. Then I can take x common in the first two terms. If I take x common, I get x into x minus 10 equals to a 0. And now it will be either x equals to 0 or x minus 10 equals to 0, leading to x equals to a 0 or a 10. So my required answer for this particular question would be option number. In the next sum, the task is to simplify the given expression, and it goes like this: 1 plus p square by 4 whole divided by 1 minus p square by 4. Now, if someone look at the term, let's say p square by 4, which I can rewrite in the form of, one can say, p by 2 whole square. So what we will do is, let's try to think about some of the known algebraic formula, namely a square minus b square is a plus b into a minus b. And again, something like a plus b whole square, which is equals to a square plus 2ab plus b square. So if I look at my numerator, which is 1 whole square plus a p plus the term p square by 4, as I told you, I can rewrite as p by 2 whole square. So in the numerator, we do get something in the form of a square and a b square term. How about the denominator? We have the term 1 minus p square by 4. Both the number 1 and the term p square by 4, I can write them in the form of whole square. Like the number 1, I can write as 1 square. Minus the term p square by 4, again I can rewrite as p by 2 whole square. Now if I look at my numerator, 1 whole square plus p, do we have any other way? Because moment you remember the term a plus b whole square giving you a square plus 2ab plus b square, I can rewrite the term p in the form of this: 2 into 1 into p by 2. So now I can say my numerator actually becomes something in the form of a plus b whole square. So 1 plus p by 2 whole square, it has 1 square, minus the term p square by 4, again I can rewrite as p by 2 whole square. Now if I look at my numerator, 1 whole square plus p, do we have any other way? Because moment you remember the term a plus b whole square giving you a square plus 2ab plus b square, I can rewrite the term p in the form of this: 2 into 1 into p by 2. So now I can say my numerator actually becomes something in the form of a plus b whole square. So 1 plus p by 2 whole square whole divided by the term 1 square minus p by 2 whole square. I can take the help of a plus b into a minus b. So 1 plus p by 2 times 1 minus p by 2. And now I can, let's say, cancel the term 1 plus p by 2, and that basically will reduce I, let's say, take LCM of, let's say, 2 in the denominator of both one minus p by 2 in the denominator. And this thing can be further simplified if I, let's say, take LCM of, let's say, 2 in the denominator of both numerator and denominator, giving you, so multiplying by 2 gives you a 2 plus p, divide by 2 minus p, which clearly mean the required answer for this particular question would be option number. In the next sum, it is divide by 2 minus p, which clearly mean the required answer for this particular question would be option number. In the next sum, it is given that which of the following is or are factors of the number 81 e power 4 minus 1. Now understand, first of all, the number 1 I can think of as 1. square. And the number 81 also is a perfect square. The number e power 4 also I can rewrite them in the form of e square whole square. So what do we have? 81 e power 4 minus 1. And the term 81 e power 4 I can rewrite in the form of 9e square whole square minus 1 square, which clearly becomes in the form of a square minus b square and can be written as a plus b times a minus b. So for the given expression, one can say the factors are going to be definitely 9e square plus 1 times of 9e square minus 1. And do you find something over here among 1, 2, 3, 4? Clearly, 9e square plus 1 is definitely going to be a factor of the expression 81e power 4 minus 1. If 2 is going to be there, so we can say right now all the options stays, because none of this basically can mean something else as well. It could be only 2, 2 and 4, 2 and 3, and something of that kind. Now, anything I can do with the term 9e square minus 1? Yes, the term 9e square I can again write in the form of 3e whole square. So 9e square plus 1 will again continue. This part I will write as 3e whole square minus 1. And now this 3e whole square minus 1, basically, which is nothing but a minus 1 square, again I can write them in the form of a plus b times a minus b. This part will become 3e plus 1 times 3e minus 1. As you can see, we are able to find out the other factor, which is 9e square minus 1, also which can be split them as 3e plus 1 and 3e minus 1. But option number 1, no. Number 2, yes. 3 square plus 1, no, we are not getting it. Fourth one, it's clearly only 2. So option A is the required answer for this. Three square plus 1, no, we are not getting it. Fourth one, in the next sum, it is given that what should be added to the term 4x square minus 16x to make it a perfect square. Now, in this particular case, I can see one of the term like 4x square, I can rewrite as 2x whole square. It already comes out to be in the form of some perfect square. So right now we can think of in the form of, one can say, a potential a plus b whole square or a minus b whole square. So right now we can see some form, most likely a square plus 2ab term or a square minus 2ab term, mostly a minus 2ab term because I can see a minus 16x term. So what we can do is, again, we can take the help of this part. The term a minus b whole square is equals to a square minus 2ab plus b square. So in short, if I possibly ask you that we have something in the form of a square minus 2ab, what will you add to make it a perfect square? And the answer basically would be a term b square need to be added. So let's see whether we can find out the value of b, and accordingly, can I find out what b square term is going to be added to make it a perfect square? So here we will write this as 4x square minus 16x. I can write the first term 4x square in the form of a whole square quantity 2x whole square. So right now the term a stands out to be equals to 2x. Let's try to split the number 16x in the form of 2 into a into b. So 2 times of 2x
बेंचो माइक म्यूटेड है। हाय हाय। ओए।
So as of now, we have got 2 into 2x giving you a 4x. What will you multiply in the term 4x to reach the number 16x? And the simple answer would be multiply by 4. So now you can see 2x whole square minus 2 into 2x into a 4. So right now the value of b happens to be equals to 4. So what are we supposed to add here? A term equivalent to 4 square. This number need to be added so that this part will become 2x minus 4 whole square. So please note this particular term, which is equal to a 16, need to be added to make it a perfect square quantity. The next sum is quite tricky, and we can look at a couple of ways to solve this particular question. It is given that find the value of under root of a lot of terms are being given, big numbers are being given, like a 2 plus 1, then a 2 square plus 1, 2 power 4 plus 1, 2 power 8 plus 1, and finally a plus 1. And the whole thing square root. Now understand in this particular case that the next bracketed term contains a power, which basically happens to be nothing but double of the previous term. So we are most likely going to take the help of a square minus b square in this particular case, and by applying cascading of those formula again and again. Now understand one thing, that if I want a term a square plus b, a square minus b square, which happens to be a plus b into a minus b, if I call this a plus b term as 2 plus 1, then what is a minus b term? Happens to be nothing but a 2 minus 1. Let's deliberately, I'm multiply by the term 2 minus 1. And let me also ask you one thing over here. By multiplying by 2 minus 1, have I made any change in the existing problem? And the answer basically happens to be no. Why? Because the term 2 minus 1 minus b term happens to be nothing but a 2 minus 1. Let's deliberately, I am saying multiply by the term 2 minus 1. And let me also ask you one thing over here. By multiplying by 2 minus 1, have I made any change in the existing problem? And the answer basically happens to be no. Why? Because the term 2 minus 1, this particular term happens to be nothing but equals to a 1. If you multiply some quantity by 1, that quantity doesn't change at all. So in this particular case, 2 minus 1 is perfectly fine. Now the point is, can this two bracketed term 2 minus 1 into 2 plus 1 can be combined with the help of a square minus b square formula? And the answer is yes, because both of them are currently in the form of a plus b into a minus b. If I do that, the term 2 minus 1 into 2 plus 1 I can represent as 2 square minus and other part basically will follow. Then if you notice now, again the next two term, the term 2 square minus 1 into 2 square plus 1 can again be combined with the help of a minus b into a plus b, and that I can write in the form of a square minus b square. So this two term will again become 2 square whole square will become 2 power 4 minus 1 square will become nothing but a 1. So now one can observe the trend that the next two term like 2 power 4 minus 1 into 2 power 4 plus 1 can again be combined with the help of the formula a square minus b square, which happens to be a plus b into a minus b. So it will become 2 power 4 whole square minus 1 square, giving you a 2 raised to 8 minus 1 into 2 raised to 8 plus 1, lastly a plus 1. Now this part, if you look at again 2 power 8 minus 1 times of 2 power 8 plus 1, I can again write them in the form of 2 power 8 whole square minus a 1 square, and that will become 2 power 16 minus 1. Again, you have a plus 1 in the end, which basically makes this result to be equals to square root of 2 power 16, which is equals to a 2 power 8 one can say. And 2 power 8 basically becomes 256. That is the required answer for this particular question. If I look at another way to solve this particular question, because many of you might ask, why have I multiplied by 2 minus 1? What about if I can't spot? The answer would be, then look for some sort of pattern here. So what I will do is, let's say we take only the one bracket, is 2 plus 1. If that is the case, if I only have one bracketed term, in that particular case, the result will become equals to root of, this is 3 plus 1, which is 4, or simply a 2 power 1. Let's see what is the result if I take two terms over here. So the first term 2 plus 1 is 3. The next term basically is 2 square plus 1 happens to be a 5 plus 1 root of, this is 15 plus 1, which becomes a 16, and that is equals to a 4, or one can simply the one bracket is 2 plus 1. If that is the case, if I only have one bracketed term, in that particular case, the result will become equals to root of, this is 3 plus 1, which is 4, or simply a 2 power 1. Let's see what is the result if I take two terms over here. So the first term 2 plus 1 is 3. The next term basically is 2 square plus 1 happens to be a 5 plus 1 root of, this is 15 plus 1, which becomes a 16, and that is equals to a 4, or one can simply say a 2 square. Now suppose if I take three terms, so the first bracket term is 3, the second bracket term we can see is 5, the third bracket term 2 square plus 1 happens to be a 17 plus 1. Now we get 3 into 5 is 15, 15 into 17 becomes a 255, plus 1 becomes a 256. Result become equal to 16, which is equals to a 2 raised to 4. So when we see the first term is there, only one bracket term is there, it's 2 power 1. When we have two bracketed term, the answer become 2 square. When we have three bracketed term, answer become nothing but 2 power 4. Clearly means, suppose if I have, let's say, 4 bracketed term, the outcome will become equals to, one can say, a 2 power 8 over here. And that is the answer for this particular. If I look at one more way to solve this particular question with the help of GP formula, so let's say if you have taken the term 2 to be equals to a, then what do we have? Let's forget about the square root part. So you have something like a 1 plus a into a 1 plus a square into a 1 plus a power 4 into 1 plus a power 8. And finally, you have a plus 1 as well. Now, in this particular context, if you look at this term, if you multiply the first and the second, will give you 1 plus a square plus a cube. Then if I multiply 1 plus a power 4 plus a power 8 plus a power 12 plus 1. And then again, if I multiply the two bracketed term, you will observe that you will get 1 plus a square plus a cube plus a power 4 and so on up to a power 15 plus 1. And this part 1 plus a square all the way up to a power 15 happens to be nothing but a GP with the first term as 1, common ratio as a, and the number of term basically being 16. And we can use the formula a into r power n minus 1 divided by r minus 1. So first term is 1, common ratio is a, number of term are 16 minus 1 divide by a minus 1 plus 1. And understand we have taken the value of a to be equals to 2. This part will become equals to a 2 power 16 minus 1. The term a minus 1 simply become a 1. Minus 1 plus 1 basically get cancelled out. So this required result become 2 power 16. But please note the objective was to find out the value of square root of this expression. So root of 2 power 16 will become equals to a 2 power 8, which happens to be equals to a 256. And that is the required answer for this particular. In the next sum, it is given that Rajni is 7 times as old as his son. After 3 years, he will be 5 times his son's age. What is Rajni present age? Now, in this particular case, we are comparing, suppose, the age of Rajni with his son. So let's write down, first of all, Rajni, son. Again, we can take the help of two variables. We can take the help